direction.
We all think like.
All right, there we go. So, the unit circle. We can already do some of these things. Do you guys remember how to explain what a radian does? How a radian measures an angle? Can you find it in your notes?
Probably.
Actively look in your notes, please.
Oh yeah. Where did we go?
1.6.
Oh, did we?
Yeah, keep going. The circle.
Radian.
What was your question?
What is a radian and how does it measure angles?
The radian is the measure of a central angle that intercepts an arc that is equal to the length. Radians are of the circle.
Okay, well, you're absolutely right. That is the textbook definition.
It's like
But
a
what does
radius.
it mean?
I don't know.
What do you mean? Say that again, Arlen.
Radius.
Oh, that is.
Okay, what do you...
Do you mean or not?
Oh, the pi rad equals 180 degrees.
That's true. That's how we convert from degrees to radians. But what is a radian?
Oh, a circumference. Square two.
Yeah, you're getting colder.
Oh.
It's half of a circumference.
Well, I guess half of Earth's circumference you're getting warmer, but that's not what a radian is again.
You never told
All right.
It's
Yes,
like-
I did too. Who said you never told us?
6.28 equals
You weren't
1.
even
here. We took the
I know. I wasn't even here
Where's
when I
the
took the notes.
pen?
All right.
So, a radian.
Oh, this is a radian.
Circle.
That's some radians.
Yeah, you guys even practiced drawing
It's
them.
what is the measure of a central angle.
She said that.
Okay, so remember degrees measures angles. If I draw this angle here, I might say that that angle is 30 degrees, right?
Yeah.
A degree is formed by splitting your circle into 360 equal parts. Kind of random, right? But a radian uses a different form to measure the same kind of thing. But we're still looking at those angles that are created, right? But remember how we started I asked you guys to start thinking about angles as rotations, not like a fixed figure that's created by two lines, but thinking of it as a rotation. I start here and I rotate that much, right? Remember that?
Yeah.
Sort of, kind of. So look how big this is. Look how big this radius is that I just created.
Do we draw that?
No.
You don't have to, but you may want to if you forgot about how to do radians.
Mm-hmm.
So here's this radius. If I took this exact length, right, and remember we had that little string,
Oh, I can go away.
and we wrapped that little string around the circle that was exactly the same length as one radius, and then we drew another line that went from the center of the circle to the end of that string, whose length was one radius. Then this angle here that we've created is 1 radian. So the length of this arc here, the length of that is equal to 1 radius, but a radius measures length, right? It doesn't measure angles. Did you hear what I just said? If you don't know it, then you probably should. Radius measures a length, not an angle. So we need to come up with a new name for the measure of those angles that we're working with. So if the length of my circle, or on my arc here, is equal to 1 radius, then the measure of my angle here is 1 radian.
He was like, right in front of my door. I was like, you're really loud.
You could have been a little bit more polite. Okay.
So is radius or radian like a unit?
It is exactly a unit, yes. So,
I'm like, you're really loud. You shut the door.
in my picture here, we have an angle, which is there, right? An angle is a rotation. I start here, and my little segment rotates this far. What was that?
I don't know what that means.
Alright,
I start here.
can you just click the middle button? You know when it's charging, it thinks you're like talking to it.
I'm not talking to you right now. Go back to sleep.
I don't know what that means.
Here, so too. Only in Trig class.
Oh my gosh. Okay. So, Sierra, what I was saying is there's a difference between the parts that we're labeling here. Okay. And I don't want to spend a lot of time on this because we already have. But there's a difference between the parts that we're labeling. So there's the angle, which is this rotation, right? An angle is different than an arc. An arc is a distance.
Isn't that
It's like how far you actually travel.
Ow.
Is the arc the double of the angle?
Yeah, so it's like 30 or 60. Oh no, it's 30.
No.
It's the same.
It's the same if the center, if the vertex is at the center of the circle. Okay? So you might say that that arc is 30 degrees, but we're not even measuring that arc in degrees right now. We're trying to measure those things in radians. And so the other thing that we said is, if we traveled all the way around the circle, circumference is equal to 2 pi times the radius. That means there's 2 pi radiuses that could wrap around that entire circle. Remember that? 2 pi times the radius means there are 2 times 3.14, which is 6.28. There's a little bit more than 6 1/4 of these radiuses that I could wrap all the way around the circle. And that's how we got to our conversion that said pi radians is equal to 180 degrees. And we use that as our conversion equation. So I'm not going to go back into conversion, but you do need to realize that what a radian is like how big of an angle you get if you wrap one radius around the circle and then you draw the segment from the center to the end point. That's what 1 radian is. Okay. So now let's talk about the quadrants. How many quadrants are there? 4. There's 4. And 6 quad. So sine, cosine, and tangent, as we've already seen a little tiny bit when working with the law of cosines. Sine, cosine, and tangent have both positive and negative values depending on which quadrant your angle is in. So we're going to look at each of the 4 quadrants separately, but just in case you have forgotten how to name them, oops, I really didn't want that. How to name your quadrants. If this is the x-axis, and this is the y-axis, what is this quadrant right here? This is the first quadrant, and in the first quadrant, both the x and the y values are positive. Stop. So in quadrant 1, both the x and y's are positive. What about in quadrant this? 2. Yeah, remember when we name our quadrants, we go in a counterclockwise direction? Okay, and in quadrant 2, my x values are negative, but my y values are positive. And then down here in quadrant 3, they're both negative. X is negative, y is negative. And of course in quadrant 4, that's a plus. Can you tell? Positive, negative.
Oh, yes.
Oh, yes.
They look like faces.
I know, they do. Everybody always says that.
Positive.
I don't know, because I mixed it and then I forgot. Thank you for paying attention. You get points for that too.
Thank you.
Alright, positive, negative. So we're going to look at each quadrant and see what happens with the sine, the cosine, and the tangent that we have here. Okie dokie?
Yep.
Artichoke? Yeah. I'm going to turn the page, okay? Stop it with the chair. Alright, so here's quadrant 1. You don't have to make this take up as much space as I did, but you can just draw yourself a little quadrant. So when our angle is in quadrant 1, I've tried to draw this. You know, these are my axes. I should put arrows on the end of them. But when my angle is in quadrant 1, what's going to happen is we're always looking at the angle that's formed with the x-axis and the positive x-axis. So if I draw one side of the angle that's the positive x-axis, and I visualize myself rotating in a counterclockwise direction, we would say this angle is in the first quadrant, right? Because the side that's formed is in the first quadrant. Now, if you look at this angle, and let's see, I'm going to move this rotation drawing that I made here for a second. And I formed a right triangle, just like this. And theta is down in the corner. Label your sides opposite, adjacent, and hypotenuse for me, will you? What's what?
Opposite.
Opposite.
Adjacent.
And height.
Hypotenuse is this guy, right?
Mm-hmm.
And then adjacent is right here, isn't it?
Yep.
Okay, so because we're moving in the positive x direction over here, this length, right? If I was going to figure out what that coordinate was, that x coordinate, and what, like a point in space, the x coordinate here would be positive, and the y coordinate here would be positive, right? Just like we looked in the last, when we did our quadrants.
Mm-hmm.
So that means the adjacent side is positive, and the opposite side is positive. So if I were to find the sine of theta, it would be a positive number over the hypotenuse, which we're going to visualize as always being positive because it's the length of that side, and length is always positive, right?
Mm-hmm.
We don't have negative distance. We only have positive distance. So we say in quadrant 1, the sine is positive. The cosine in quadrant 1 is also the adjacent over the hypotenuse, and the adjacent side is positive. So the cosine in quadrant 1 is also positive. And because the tangent of an angle is equal to its sine over its cosine.
Wait, can you?
Yeah, can I move?
Yeah, give me a sec.
Yeah, I'll give you a sec to catch up too. But because both the sine and the cosine are positive, we know that the tangent is also going to be positive. So basically in quadrant 1, everything is positive. Yay!
Why is it tangent? You see it?
Remember how tangent was opposite over adjacent? And then we could say that the sine is opposite over hypotenuse and the cosine is adjacent over hypotenuse. And if you divide opposite over hypotenuse by adjacent over hypotenuse, you get opposite over adjacent. So they're equivalent. It's another way of defining the tangent. All right. Can I move to the next page?
Yep.
Maybe not. Okay. Oops. Oh wait, I'm just kidding. Quadrant 2 is down here. So here's quadrant 2. Notice the position of that third side is in the second quadrant, but we're still forming the angle with the positive x-axis, so it's formed by that rotation there. But I can't create a right triangle to the positive x-axis. So what I do is I create my right triangle with the negative x-axis, right? Mm-hmm. This is what we call a reference angle. I don't know if you want to call it theta 2.
Beta?
Theta. You go with that.
Wait, what's beta?
It's just a different name.
Oh.
Oh wait, no. Okay.
Wow.
If I want to find the sine, the cosine, and the tangent of theta, then what I'm going to do is draw that line down to the negative x-axis so that I can create a right triangle. And when I've created that right triangle, then I get this little angle with the negative x-axis and that side, and that's called a reference angle. So what we're going to do is find the sine, cosine, and tangent of this reference angle, and define that as being the sine, cosine, and tangent of this bigger angle theta. No, can you ask Teresa? Oh, awesome. Sorry, Vero. Are we cool there? So if I wanted to find the sine of theta, it's going to be equal to the sine of theta 2, my referencing. And in this particular picture, we still have opposite because we say it is. It's how we that's how we're defining sine, cosine, and tangent in the coordinate plane. Because it's going to work for us. You know how there's certain things in math that are like, well, we're going to call it that because we want it to be that, and then we're going to see what happens with the math when we do it that way. This is one of those things. Now, since we're in the positive y direction right here, we say that my opposite side is positive. But what's not going to be positive in this picture? The adjacent side. Yeah. Because we're going in the negative x direction, we say that our adjacent side is negative. So in this particular case, my sine is going to be opposite over hypotenuse, which is still positive over hypotenuse, which is still a positive number. But my cosine is going to be negative. And if my sine is positive and my cosine is negative, and the tangent is opposite, or sorry, sine over cosine, the tangent's going to be positive over negative, which is also negative. So in summary, in quadrant 2, the sine is positive, the cosine is negative, and the tangent is negative.
Wait, I don't get why
Yeah.
equals when you finish.
Over cosine.
Okay, number 1, remember how we had the different definitions for tangent, and they're also on your bookmark? So, Martin asked about this just a second ago as well, but tangent equals opposite over adjacent, right? So what happens if I divide sine by cosine? The sine was opposite over hypotenuse. The cosine was adjacent over hypotenuse. Remember how you divide fractions? You don't have to write this down. You flip and multiply, right? So opposite over hypotenuse times hypotenuse over adjacent. You get opposite over adjacent. So if I divide the sine by the cosine, I get what I've defined as the tangent. So tangent is opposite over adjacent. It's also equal to the sine divided by the cosine. And that's important to know because we're going to need it when we're calculating the tangent in our unit circle. Yeah?
But they just said that they can't be negative.
You didn't say they can't be negative.
She said distance can't be
I said distance can't be negative. Yeah, thank you.
But angles can be?
Angles can be negative. Sines can be negative. Cosines can be negative because they're just ratios of sides. And part of that, Lauren, is because we're defining how to figure out sines and cosines in this coordinate plane, right? Before, when we were looking at sines and cosines, we were only talking about sides of a right triangle. And in a right triangle, my angles always have to be between 0 and 90 degrees. So what if I want to extend outside of the land between 0 and 90 degrees? I have to come up with a way to do it, right? So the way that we do that is we say, all right, we're going to look at what's going on with my x and y values and set those signs SIGN, positives and negatives, for the opposite sides and the adjacent sides. Whether they're positive or negative is going to represent what's going on with the sine and the cosine. Okay? So if my angle is over here, There's a really easy way for me to make a right triangle out of that, right? Which is to drop down this side right here. But over here, all my x's are negative, and my y's are positive. So that means that my adjacent side is always going to be negative. Adjacent over hypotenuse, we're saying, is negative. Okay, and it's kind of like, remember when you learned about imaginary numbers? And you know how you said like the square root of -1 is I? No, some of you, did you learn about that, Lauren? Like imaginary numbers? And the square root of -1 is I? Well, why is it? Well, because we said it is, right? It's like there's no, it doesn't follow from anything else. We've just said this is what it is. And that's what we're doing here. We're saying if I want to actually find the sine, cosine, and tangent of this angle, well, I look at this triangle to do it, and I look at whether or not the sides of that triangle are positive or negative in the coordinate plane. Because we decided that's how we're going to do it. And when we do it that way, all sorts of cool stuff happens. When we start to graph the functions, and also we can use those functions to model all sorts of cool things, like light waves, and sound waves, and wave waves, and pendulums, and things that you do in physics, springs. Okay, quadrant 3. What's going on in quadrant 3?
Negative.
Yeah, negative stuff. What's going on in quadrant 3? So in quadrant 3, here's my reference angle is here. My angle that I want, theta, goes from the x-axis and rotates all the way around that far. So this is a big angle, right? Remember, angles are rotations. So we start here, and we rotate all the way around to here. But in order to find the sine, cosine, and tangent of that giant angle that I've just created, we draw the right triangle to the x-axis, and then my reference angle is there. So if you were looking at this point right here, what is the y value of that point? Positive or negative?
Negative.
Negative. And what is the x value of that point?
Negative.
Also negative, right? Because you went in the negative x direction. The hypotenuse is always positive because distance is positive. So we could say that the sine of theta is going to be negative over the hypotenuse, which is negative. The cosine of theta is negative over the hypotenuse, so the cosine is negative. What about the tangent?
Negative.
If you prefer to think about it as opposite over adjacent, you can think about it that way as well, instead of sine over cosine. The opposite side is negative, the adjacent side is negative, and a negative divided by a negative is
Positive.
positive. So in the third quadrant, the tangent is actually positive. Where else was the tangent positive?
In quadrant 1.
In quadrant 1. Because everything is positive in quadrant 1. Yay. Positive everything. Yeah. Nice.
Where?
Here. See, she circled it. Positive everything. Okay. Now, quadrant 4. Here it is. If my side is in quadrant 4, this is a super big angle. The theta that I'm interested in is that whole big angle, that whole rotation. Boom. But my reference angle, there's my right triangle, my reference angle is there. In this particular case, my x values are positive, but my y values are negative, right?
Wait, Miss, so we don't really need theta then?
You do need theta because that's the actual angle that I'm interested in. So, Arlen, remember, we wrote this on the other page. I didn't write it up here. The sine of the theta that I want is equal to the sine of the reference angle, theta 2. And in this case, my opposite is here. My adjacent is here. So my opposite side is negative. So my sign is going to be positive. I mean negative. Jerk. Sorry. The cosine. Well, in this case, my adjacent side adjacent to theta, is positive. So my cosine will be positive. And my tangent will be what?
Opposite over adjacent.
Okay, opposite over adjacent, which is going to be negative over a positive, which is
Negative.
a negative. Beautiful. Alright, so let's summarize that information. Overall.
Does it need to be big?
No, it doesn't need to be super big.
Just medium.
Okay, so I just did in black because that's the standard color. So my axes, X and Y here. Where was the sign positive?
On the first one.
In the first one, and?
And
No, second, fourth.
second. Second.
1, 2, 3, 4.
Wait, what's the
So where was the sign positive?
first and third?
First and second.
First and second. The sign was positive. Where was the sign negative?
Third, yeah.
Third and fourth, right? Where was the cosine positive?
First
Mm-hmm.
and
Fourth.
First and fourth, good. So in the first and fourth, the cosine was positive.
oh, it's making it a circle.
And where, yeah, because I drew it that way, but yeah. Where was the cosine negative? Yeah.
The other two.
The other two, which
and
is
three.
2 and 3. So the cosine is negative over here. All right, next color. Where was the tangent positive?
First and third.
First and third. So tangent was positive here, and the tangent was positive here, which means it was the other two, 2 and 4, where the tangent was negative. So they're kind of kitty corner to one another, right? You get your tangents here and here. So what do you notice about where the sign is positive?
On top.
It's on the top. Okay, relate that to the coordinate plane. What else is positive in the top two quadrants?
No.
Why?
The Y.
Oh.
Yeah, you have to think about it for a minute, but you've got it. The Y's are positive in the top two quadrants, right? And what's really happening is, remember when we drew those angles, even if we do it in the first quadrant right here, well, actually, let me take that circle away. Even if we do it in the first quadrant, there's my hypotenuse, here's my angle. Where was the opposite side? It was over here, but that's that vertical distance. Exactly. That's represented by the Y values, right? So the Y values are always going to tell you the sign of the sign. The sign of the sign. I know, a little weird, but the Y values are always going to tell you if the sign is positive, it's up, negative, if it's down. And similarly, cosine is always going to be described by the adjacent side, but the adjacent side is measured by the x's, right? So you see where cosine is positive? Well, cosine is positive when my x coordinates are positive. And cosine is negative when my x-coordinates are negative. Tangent works a little bit differently because it's a quotient of the sine over the cosine, but tangent is positive when sine and cosine are both positive, and it's positive when sine and cosine are both negative, because a negative divided by a negative is positive. And then it's negative when one of them is positive and one of them is negative. Cool?
Yeah.
Alright. I think this is actually one of the most helpful pictures in starting to figure out how to do trigonometry in the coordinate plane, especially with your positives and negatives. I always come back to this graphic quite a bit. So now let's use that information to actually do some trigonometry. So write down the first example, and please write down the words so that when you're doing your homework, you have an example that you know what the directions were. It will be helpful. Okay. So we want to find the exact values of the trig functions for theta if the endpoint of the angle is -5, -12. So where's -5 and -12?
Coordinate 3.
No, because they're both negative.
Why didn't that go away?
No, it's the third one.
3.
Yeah.
Yes.
Yeah, you left it on your table.
No, I don't know.
You can have my tape if they all come back because
I
I
promise.
just had to take out 3 new tape dispensers because people have been stealing them.
I've been
Did you
bringing
know
them
that
back,
they're
I
in the copy
promise.
room? They're in the copy room.
guys. I've
I
got
saw them
4.
in there the other day.
I'll bring back 4.
Okay.
Thank you.
I'm on video. I have to be nice. Okay. So where is -5, -12? Which quadrant?
Third.
Third.
1, 2, 3. Yeah. So if we went, well, let's get a nice little line here. We'll do it like this. Okay. So if we went back 5 and down 12, that's where we would be. So here's a point. All right, so we've graphed that point, -5, -12. The angle that we're interested in starts from the x-axis and spins all the way around that way.
I didn't know it starts there.
Because it always starts there. Because we said.
Is it because it's positive?
You could certainly find trig values of those different angles, but they wouldn't be defined the way that we're defining these angles. So again, it goes back to, it is because we say it is, because that's how we want to define it.
Is that supposed to be theta?
Yes, that's supposed to be theta.
It's like a little clock.
Is it a clock?
Okay.
Theta?
So, if I want to find the sine, cosine, and tangent of theta, then what I need to do is look at that little right triangle right there. If you want to draw it, we can. What's the length of this side right here?
5.
-5. It's -5. And what's the length of this side right here?
12.
-12. Good. And what's the length of this side right here? Pythagorean theorem.
No.
-5 squared plus -12 squared equals c squared. That's 25. That's 144. Add them up, we get 169. Take the square root. We get 13. You want to trust me on that one?
Yeah.
It's helpful to know your Pythagorean triples. 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25. Yada.
So it's positive 13?
Yes. Pythagorean triples are when you have whole numbers that satisfy the Pythagorean theorem. 3, 4, 5, 6, 8, 10, 5, 12, 13,
Oh.
7, 24, 25, as opposed to like root 2, and 2.
Hypotenuse will always be positive.
Hypotenuse will always be positive. Okay? So now that we have this, My angle that I'm interested in is
Here you go.
my reference angle. Theta 2 is right there.
I see.
So if this is theta 2, this side is the opposite, this side is the adjacent, and this side is the hypotenuse. So what would the sine be? Opposite over hypotenuse.
Negative 12 over 13.
Beautiful. What would the cosine be?
Negative 5 over 13.
Negative 5 over 13. Beautiful. What would the tangent be?
Negative 12.
No, yeah.
Opposite over adjacent, so
Is this theta or theta 2?
both.
Theta 2.
Doesn't matter.
Alright. So,
So the tangent's actually positive, right? Because it's negative 12 over negative 5, which is 12 over 5.
See the notes like that?
I don't know. I thought it was going to go away, but whatever.
Well,
Could we find the secant?
yeah.
Secant is the flip of which, sine or cosine?
Sine.
No!
The cosine.
Yes. So the secant would be 13 over negative 5. The cosecant would be 13 over negative 12, or negative 13 over 12. And the cotangent would be 5 over 12. Bueno?
Wow.
Me too.
Do you want me to help you? All right. Example 2.
Well, tomorrow we don't have notes. Just today.
Wait, is there a catch?
Is there a catch?
yeah.
No. Why do you have investigation? Do you want me to tape your eyeballs open?
No, there's
I
no
just
burning.
after lunch, I
You
was
see
like,
that?
I don't have any tape.
You see
foggy? Because
You don't have
She
to.
has a staple or something.
Blah, 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 blah.
All right. State the quadrant in which theta lies if the sine of theta is less than 0 and the cosine of theta is greater than 0. What's that secret code language for saying?
I can't see the board.
What does this mean? The sine of theta is less than 0. What's that really saying?
Negative?
Yeah, this is really saying that the sine of theta is negative. The cosine of theta is greater than 0 is really saying that the cosine of theta is positive. So remember, where is the sign negative?
On the bottom.
On the bottom. So sine is negative. Whoops. Sine is negative down here. We could highlighter it. How do I do that? Highlighter it.
Crayon it.
So sine is negative all the way down here. Alright. Where's the cosine positive?
On the left.
On the wait, I just heard right, left, and side.
On the
So
left. I mean right.
it's cosine is positive when
On your.
what is positive?
When the sign is
Say it again. When the x is positive. Cosine is positive when the x is positive.
Yeah.
The x's are positive over here. I can highlighter it. Let's do it. Highlighter! Let's do it.
Where was
just do that with her.
It's still green.
It's still green.
Yeah. Maybe when you turn green.
Oh, magic.
You should try the crayon.
I know that's what I told her.
Oh, sorry, I wasn't listening because I had highlighter in my brain. So, what quadrant does theta lie in if its sine is negative and its cosine is positive? How do you know? Because that's where it's overlapping, right? Theta must live here.
Wait, I should do that. They're more different.
Theta must be right here because that's where the sine is negative and the cosine is positive. So,
What was your question?
My answer is quadrant 4.
Wait. No. Wait, where's theta? Cosine is positive.
Theta is, I don't know how to draw this. Theta is this rotation. You start from the x-axis and you rotate to there. That's your theta.
Here.
So, that.
Wait, so it's their y?
Really, this is why you take up a whole book. Okay, what? Say, no. Reasonable question. I won't yell at you.
I forgot. Oh, yeah, why is it right there? Because the sine is negative and the cosine is positive?
Yeah, theta has to be right there. It can't be over here. It can't be over here because the cosine's not positive there. It can't be up here because the sine's not negative. This is the only place where both the sine is negative and the cosine is positive. So it might not be in exactly this location. I mean, it might be over here. It might be up here. But it's like somewhere in that quadrant. I do this a lot. Did you know that?
Yeah.
I watch myself on video and I do this a lot.
What?
What is that?
Yeah.
You want that?
Yeah, this.
The hand.
The hand. Well, I'm waiting for you guys, especially. Doesn't it bother you that I do that?
No.
We don't even
You wouldn't even notice.
Like if it like soothes me.
Oh, the tap, 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 tap,
Yeah,
tapping
like,
on the door.
I do.
Alright, you ready for the next one?
How many are there?
No, that's weird.
Oh my gosh.
But
No, that's going to be on the internet. Did you guys watch the Grammys?
I'm Rihanna though.
Oh my god.
Oh yeah, I saw that.
What? It's up.
I know everybody keeps talking about
Something like
Rihanna,
that.
but
It was everywhere.
I
I didn't even know.
Sample 3. So how can we find the rest of the trig functions if we know that the cosine is negative 2/3 and we know that theta is in the second quadrant? I just read it out loud. I didn't even start anything yet. All I did was read. I could read it slower.
Yeah.
And find the values of the remaining. That's just patronizing. I'm sorry. All right.
Functions of what? Doing this.
You put it in. If
How do you talk
okay.
she started it.
Technically, we're in a six.
Just hanging out with people that are.
You might be able to sit in the science.
Yeah.
What?
We're in the science too.
Channel 8.
Oh my gosh.
I look for you.
Oh, Gerald.
I can just imagine saying that. I'm looking for my friend.
Okay, let's read this problem. Stop. Alright, we had our little brain break there. Let's do example 3. So let's find the values of the remaining trig functions if we know the cosine of theta is negative 2/3 and we know theta is in the second quadrant. Everybody should tell me what's the first step.
Draw the quadrant.
That
was everybody.
Thank you, Lauren! What's the first step? Draw the picture, right? Alright. Okay.
Alrighty.
So, give yourself a graph.
Alright, guys.
Does
Let's
not
reconsider.
What do you mean? It doesn't matter. It doesn't matter. It doesn't matter. It does not matter. It does not matter. Now, where is my angle going to live?
quadrant
no, I
negative.
messed up, yeah.
It's where?
Quadrant.
Quadrant 2. So I'm going to start from the origin right here. And I'm just going to draw my angle somewhere into quadrant.
Doesn't matter where you put it.
Well, I mean, if you wanted to be exact, you could be exact. You want to be exact?
No.
Okay, then don't worry about it. Just put it somewhere in the second quadrant. Cool? Alright. Now, the theta that we're interested in is this guy. But the triangle that we're going to look at is over here, and we're going to look at that reference angle. Now, I know that the cosine is negative 2/3. I also know that cosine is adjacent over hypotenuse. So what could I label in this triangle?
The side.
Okay, which ones?
-2.
Yeah, negative 2 and
3.
positive 3. 3 is going to be the hypotenuse. No, 3 is the bottom, right? It's going to be the hypotenuse. And then where am I going to put negative 2?
On the
On the bottom. It's the adjacent, right? It's the x coordinate. Cosine is negative when x is negative. So cosine is represented by those negative xi's. Okay? So if I'm going to find the rest of the trig functions, I need to know it's the square root of 5. Want to work it out for me real quick, Lauren?
So we could
That got loud?
2
Yeah.
squared.
Yep.
Plus b squared.
Speak up so the thing can hear you.
Okay, so negative 2 squared is equal to 4.
Yep.
Plus b squared is equal to 9.
Yep.
We subtract 4 from both sides. 5. And the square root 5. Square root 5.
And then the square root of 5 is the square root of 5. Beautiful. And is that going to be positive or negative? Think about it for a minute. Why is it positive?
Positive because the y is going up, so it's positive.
Positive because it's in the second quadrant where my y's are positive.
You can't have a negative square root.
Well, you can't have a negative square root, Lauren, but if we were in a different quadrant, like if we were down here, it's not the number inside the square root that would be negative, but it would be like negative root 5.
Negative root 5.
No, because
But you can't have, you can't do that.
it.
My old teacher said you can't do it. You have to make it negative 5.
Yeah,
You wouldn't be taking the square, it's the difference, you would not be taking the square root of negative 5. You wouldn't get to this point where you would say, well, let's look at an example in a second, because I don't want to do it in the middle of this and like get all confused, but let's do an example in a second so you can see, you're going to apply the sign, S-I-G-N, the positive or negative, after you figure out the length, based off of what quadrant it's in. But you're right, you're not going to take the square root of negative 5. I think we should go over that because I don't want you to be confused and you're just like, that's because you're shutting down a little bit.
I know.
Stop it.
What?
Okay. We've got our triangle set up, right? Since we're in the second quadrant, the sign is going to be positive. We haven't found the values of the remaining trig functions.
God
I
damn.
made another graph.
Oh my god. Next problem.
What's the sign of theta going to be?
Positive?
Positive what? So what's it going to be?
3.
I mean,
5 over 3.
Okay. We already know the cosine. What's the tangent going to be?
Oh god, we brought a square root. Opposite.
negative 5.
Negative 5.
Or 5 over
Negative 2.
Opposite over adjacent
So
would be root 5
over
over negative 2. Or you could just say negative 5 over 2.
Mm-hmm.
And then you could find the secant by flipping the cosine. The secant would be negative 3/2. You could find the cosecant by flipping the sign, rationalizing it. You could find the cotangent as well. But we had to do all 3 of those ones.
We get it.
Yeah, Oh, look, that was going to be it, but I'm going to do another example.
No!
Stop it!